Atomic theory. Dear students, today we are going to discuss about atomic models. Number 1, solid sphere model. Number 2, plum pudding model. Number 3, nuclear model. Number 4, planetary model. Number 5, quantum model. First of all, let's discuss about atomic theory timeline. 1803, solid sphere model. Solid sphere model was presented by John Dalton. According to John Dalton, atoms are dense and solid with no internal structure, are subatomic particle considered. Model number 2, 1897, plum pudding model. This model was presented by Sir J. Thomson. According to this model, atoms are described as uniform, positively charged spheres with electrons embedded within them, similar to raisins in a pudding. 1911, nuclear atomic model, presented by Ernest Rutherford. According to this model, atom consists of a small, dense, positively charged nucleus at the center, with electrons orbiting around it, similar to planets orbiting around the sun. 1913, planetary model. This model was presented by Niall Bohr. Electrons move in quantized, discrete energy levels around the nucleus and emit or absorb energy when transmitting between levels. 1920s, quantum model. This model was presented by Irving Schrödinger. According to this model, electrons do not have definite orbits but are described by wave functions that represent probability distribution of their locations. John Dalton, a British chemist and physicist, he proposed the solid sphere model in the early 19th century. Main points. Number 1. Shifted from philosophical ideas to scientific theory. Number 2. First atomic model based on experimental evidence and quantitative observations. Number 3. This theory paved the way for the development of modern atomic theories. Solid sphere model. According to this theory, atoms are tiny balls that cannot be broken down and are all made up of same material. This theory helped to explain how different chemicals mix together and what make them different. Atomic theory. This theory has following limitations. Number one, could not explain differences in atoms and their masses within an element, such as isotopes. Number two, didn't account for the presence of subatomic particles like protons, neutrons, and electrons. Number three, could not explain the behavior of atoms in chemical reactions. J. J. Thomson, an English physicist known for his work on the nature of electrons. He proposed the plum pudding model in the late 19th century. Main points of J. J. Thomson's theory. Number one, this theory discovered electrons as distinct particles. Number two, shifted understanding from undivisible atom to subatomic particles. This theory paved the way for further exploration of atomic structure. Plum pudding model. According to this theory, atoms are like plum pudding with tiny positive charges scattered throughout a cloud of negative electrons. This theory helped to explain why atoms have a neutral charge overall and why they emit light when they collide with each other. Plum pudding model has some limitations. Number one, could not explain why electron did not collapse into the positive sphere. Number two, failed to predict the distribution and arrangement of electrons. Number three, lacked explanation for the nucleus and its positive charge. Ernest Rutherford, a New Zealand-born physicist known for his contribution to nuclear physics, he introduced the nuclear model in 20th century. Main points. Number one, this was the first model to propose a central massive nucleus. Number two, explained the behavior of positively charged alpha particles in the gold foil experiment. This theory laid the groundwork for understanding atomic structure and radioactivity. Nuclear model. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through a bounds of atoms and is the base for our current understanding of atomic structure. There are following limitations of this model. Number one, did not explain the stability of the nucleus against electrostatic repulsion. Number two, lacked details about electron orbits and energy levels. Number three, did not incorporate the principles of quantum mechanism. Niall Bohr, a Danish physicist known for his pioneering work in atomic structure. He proposed the planetary model in the early 20th century. There are following main points of Bohr's atomic theory. Number one, this theory explained atomic structure with precision. Number two, this theory introduced the concept of quantized energy levels. Number three, this theory reached classical physics with emerging quantum mechanics. Now let's have a look on planetary model. According to this theory, electrons orbit the nucleus of an atom in specific energy levels or shells. This theory helped to explain why atoms emit light and why they absorb certain colors of light. It also helped explain the stability of atoms and why they would not fall apart. Limitations. This theory has following limitations also. Number one, it is limited to explaining the hydrogen atom. Number two, could not account for the behavior of multi-electron atoms. Number three, did not incorporate the wave-like nature of electrons. Irving Schrödinger, an Australian physicist renowned for his contributions to quantum mechanics. He proposed the quantum model in the 1920s. Main points of this theory are: number one, quantum mechanics provide a comprehensive understanding of electron behavior. Schrödinger's model successfully explains multi-electron atoms. Number three, quantum mechanics is the foundation of modern atomic theory. Quantum model. According to this theory, electrons exist as a probable wave-like pattern around the nucleus, not in a specific orbit. It explains why electrons act like particles and wave, and is the foundation of our understanding of atomic structure and widely used in modern physics. Limitations. This theory also has some limitations. Number one, it is mathematical complexity of the model. Number two, requires advanced mathematics to calculate electron probabilities. Number three, does not provide a simple visual representation of atomic structure. Now it's your turn. Let's test your understanding about atomic theory. Are you ready? Come on. Question. If atoms are solid spheres, what would happen if you tried to cut one in half? Guess the answer. You have some seconds. Let's understand the answer. The question was, if atoms are solid spheres, what would happen if you try to cut one in half? The answer is, in the solid sphere model, atoms were believed to be invisible, so you could not actually cut one in half. It was thought that atoms were the smallest fundamental building blocks of matter. Next question. How would you describe the distribution of resin electrons in the atomic body? Guess the answer. You have some seconds. Let's have a look on the answer. The question was, how would you describe the distribution of resins, mean electrons, in the atomic body? The answer is, in the plum pudding model, the resins, mean electrons, were thought to be scattered throughout the positive pudding atom. So, the distribution of electrons was assumed to be relatively uniform within the atom. Next question. What did Rutherford's gold foil experiment reveal about the atomic nucleus? Guess the answer. Again, you have some second. Let's check your understanding. The question was, what did Rutherford's gold foil experiment reveal about the atomic nucleus? The answer is, Rutherford's gold foil experiment revealed that most of the atom's mass is concentrated in a small positively charged nucleus at the center. This discovery overturned the idea of uniformly distributed positive charge. Question. Why might electrons be compared to planets in a solar system within Bohr's model? Guess the answer. The question was, why might electrons be compared to planets in solar system within Bohr's model? The answer is, Bohr's planetary model drew an analogy between electrons orbiting the nucleus and the planets orbiting the sun. It simplified the complex behavior of electrons, suggesting they had quantized energy levels like planets have orbits. Question. How does Schrödinger's cat relate to the concept of electron probability clouds in the quantum model? Guess the answer. The question was, how does Schrödinger's cat relate to the concept of electron probability clouds in the quantum model? The answer is, Schrödinger's cat is a thought experiment in quantum mechanics, not directly related to electrons. However, it is illustrated as the probabilistic nature of quantum systems, similar to how electrons are described by probability clouds in the quantum model. The cat is in a superposition of state, both alive and dead, until observed. Much like electrons can exist in multiple states until measured. Thank you for watching. Please like, subscribe, and share.